Hi, today I, Nitin Goel, with my fellow teammates Chawi and Manohar, will present to you MNC language. This is a language that we designed for SCR 502 compiler design course. These are the contents for the slide as we go about it. So let's move on to the language constraints. Here we could see that our language supports global and local variables. We support primitive data types as integer and boolean. We even have array as a data structure to actually have an array of integers or array of boolean. Then we support arithmetic and logical operations on these primitive data types. For decision constructs, we have if and else, and we have a loop statement for an iterative execution. We even support function implementation, and our function implementation is stack based, so it supports recursion as well. Next, about the intermediate code, we have assembly resembling intermediate code, which is we are using a 3 address code named as quadruples. Here we have opcode initially, which determines the functionality that our operation is going to do, followed by 3 operands. We need to have the operand 1, but operand 2 and operand 3 could be optional. We look into it later on. Next, look at the tools. We use Antler 4 and Eclipse for a scanner parser, and for the runtime we had Python 3.5. Now let's understand our language grammar. Our function execution starts from main, where we have a main keyword over there. Then we have primitive types as number and boolean, which are number, colon, and then the identifier for it, or boolean, colon, and then the identifier for it. To keep it something similar, we have same thing for the functions as well, function colon and then the function name. Along with it, we have in parameters for our function and the out parameters for our function, which are in, then the data type, and then the identifier for it. Our if statements, our loops, and our functions are all enclosed within start and end. Now let's try to generate intermediate code. So the intermediate code we have here is for sorting. It's a bubble sort implementation. It shows a loop within a loop. We have loop 1 and we have loop 2 over here. These two loops try to sort our data structure number C, which is of length 5. So this was our high level language where we have even the print statements for each of the index for an array, and we have even initialized a value for that particular array down in the main function. If we look at the right side on the command prompt, we have java -jar and run.jar, which is a runnable jar file for our parser and the scanner. Our file is executed at C runtime loop within .mnc file, and we run it. It compiles successfully. So after the successful compilation of our code, we could see it generated a .mnc C file, which stands for .mnc compile file. Here we have our intermediate code. It starts with LBL sorting to show that it's a label for a function sorting. And if we carefully observe over here, we will find main starting from SRT. Our SRT denotes that a main is starting as start, and we end it towards an HLT, which means halt or end of a main. Now let's move back to our presentation. So understanding a bytecode. A symbol table.py acts as a regular symbol table where it stores and maintains our symbols, all the identifiers, functions, and every other value corresponding to it. Next, we have processor.py. This one actually processes our .mncc file and executes the file in Python. Next, we look into processor.py. Our processor.py has preprocess and process. Preprocess is used to actually identify all the global variables and the function parameters. It also identifies the line number for our main, that is SRT. Next, we look into process. Process is where we create our symbol table, store all the local variables, and execute line by line all the commands for it. Now we try to understand our intermediate code commands, that is our opcodes. As I mentioned, we have SRT and HLT at the start and our end of a main. This is where from SRT is where the execution starts and HLT is from where the execution stops. We have var where when we declare variables of boolean, integer or array. We have EQL to assign variables value, and we have EAR to assign array some value. We have out to print, and we have add, sub, mul, div opcodes for arithmetic and logical operations. We have LBL for any of our jump statements which we encounter in function, loops or if else constructs. Then we have IPT and OPT which define in parameter and out parameter for a function. Moving ahead, we have par, which is used as a parameter when we call a function and we pass an argument. We have jump for the jump. We have JEQ, JNE, JGT, and all others, which means jump equal to, jump not equal to, jump greater than equal to, and so on. We have $in, which represents that there is an input for this. Now we look into how our intermediate code is actually executed and brings about an output for our program. Let's begin. We have LBL foo10. What does it mean? That it means it's a label foo, that means it's a function which has one input parameter and one output parameter, which gets converted into defined function foo in our preprocessor. Let's say we have IPT num n-1, which means that it is an in parameter to our function and it is a variable because -1 is for variables. Then we have out var n-1, which means it's a print statement for our variable n. Then we have label foo end. It means that the function foo is ending over here. Moving ahead, we have SRT, which is the main of our program. And now we have var num n-1, which defines an n integer in our main. We have n equals 15 as EQL n15. Now we define a parameter n into our function. Now we define n as a parameter to a function foo by par n-1 and then jump to function foo. And towards the end, we halt our main program by HLT. Now let us see how does the previously compiled piece of code will actually execute. Now we come back to our code and on the left side we see an intermediate code, and let's have a look at a high level code. Here I have selected an array. It is an unsorted array, and let's try to run and execute. If it shows an sorted array, then we have successfully compiled a code. And there we have 10, 7, 6, 3, 2. This is a sorted array. Now let's look into another sample program of factorial which implements factorial by recursion. On the left you could see a high level factorial code with function factorial. This function is called recursively within itself, and from our main we call a factorial with I. This I is given as an input from the user. Now let's try to compile this code and see what it does. We successfully compile this code and the output is generated. The generated output for the compile time is this .mnc file for the factorial.mnc file, which is the intermediate code. Now let's try to run this file. Here we are asked for an input. Let's give 5 as our input, and if we get 120 as our answer, this means that we successfully executed our code. We get 120. Let's give it one more try, and this time I'll try it with factorial of 6 and we get 720. This is the exact execution and the right answer for factorial of 6. That's it from our end, and thank you for the opportunity.